Another thing is flat's not a shape, and nobody here is claiming that Earth is some kind of pizza planet space frisbee disc in space.
Fact.
I'm just saying, nobody's claiming that. The cartoon that you've likely seen many times, that is not what anybody is saying.
And then what are you saying? So you're
Welcome
just
to the
saying
floor.
that the Earth. So you're saying just
Fugazi.
that the Earth is not round.
Fugazi,
Yes.
you observe, everybody, every human that's ever lived has observed the Earth to be flat and motionless.
No, that's not true.
Okay.
That's just not true. The Egyptians.
Okay.
The Greeks.
They did. Okay. So where did they go to observe the Earth is not flat and motionless?
Where did they go? Like, what do you mean? Where did they go?
Yeah. What did they see? What did they look at to know that the Earth is not flat and motionless?
They had some proofs. They had proof with a ship.
Give me one.
Map. You see the map. Like the ship goes away into the horizon, and the only thing you see is the tip of the ship. Like this is one of the proofs. Another.
Okay. We're not going to gish gallop though. We're going to go one by one. Okay.
Yeah.
Now, why do you think that? Shut up, dude.
So I just want to say one thing. Like you were going to.
No, you said something. Now it's my turn to talk. Okay, that's how this shit works. Okay. Now, seeing the ship disappear, hull first, then the mast, is not seeing the Earth as a globe. How would that be seeing the Earth as a globe?
Because like the ship is disappearing into the curvature of the Earth, and that's.
How do you know that's the curvature? How do you know that's the reason why the ship is disappearing?
Well, what would be another reason for this to happen?
Perspective.
Okay.
How do you know? The question was, how do you know?
Yeah, and you asked me a question. I asked you how that, and then you asked me the question.
Like this is just one basic single proof. You're right.
It's not proof. You can't even answer. How do you know that's the reason? How is it a proof? You don't even know why that's the reason.
Fugazi,
but like this is not.
Fugazi, your proof must be something else. You're using the Earth curvature as an excuse why the ship disappears bottom up. That means you must have another proof aside from that.
I just have a question to you. Like, if this happens, and we can all agree that this happens, okay? We can maybe
it only happens sometimes.
Yeah, all right. Sometimes not. But we can assume that the reason for this might be a flat Earth, not a flat Earth, a globe. That the Earth is round. This might be a reason for it.
Right.
We can all agree on this,
you're posing a potential reason. It's not.
Yeah, this is a potential reason. And then we look at other things.
So how do you find out if that's the reason?
Yeah, that's a good question. So we use other things and we try to measure other things, and then they also are true. And then we have many different
measurement?
things.
Where's the measurement?
You can stack 20,000 assumptions and it doesn't prove anything. Okay?
No,
you said, hey, this could be a reason. Shut up, dude. Why are you interrupting? So you got, okay, this could be the reason why the ship's disappearing. And then you can mention another thing. And it could be a globe, and that could be the reason for that. And it could be a globe, and it could be this reason for this third thing. And it could be, you have a bunch of could be's.
Yeah, that's right.
Yeah, nothing. You said they knew the Earth was a globe.
Yeah, they assumed that the Earth was a globe, and they were right.
I said, how did they observe? They did not observe the Earth to be a globe, dude. They made it up in their head.
Yeah, like they had an assumption that the Earth was round. Because
that's right. That means it's an idea. It's not observed. Observed means perceived with the senses, right?
Yeah.
So they didn't perceive a globe with their senses, right?
Not directly, but indirectly, yes.
Okay, no. They didn't not even indirectly, okay?
Oh, no.
They made up in their head, hey, I see a ship sail away. I can't imagine how that would happen on a flat surface. So it must be happening on a curved surface. But that's an idea.
Yeah.
But they didn't see that. Yeah. But they didn't see the curved surface, did they?
They just assumed it to be.
Yeah, okay. They just assumed. So they didn't observe the Earth to be a globe. So what they saw was flat water extend out to a line. And something's past that horizon line, and it appears sometimes to disappear bottom up. And they said, hey, dude, that happens on a curved surface. They were wrong because that happens on a flat surface too.
Why? Because of waves or what?
Who cares why? No, who cares why? We can demonstrate it happening on a flat surface. It doesn't matter what the why is.
So, but the flat surface.
We can do an experiment. We can do an experiment on a large flat surface, and we can get the exact identical optical effect. So we've done an experiment. We eliminate curvature as a variable, and we get the same result. Doesn't matter why. Because hold on, Fugazi. The claim is this. The conclusion is this can only happen on a curved surface. This, I see the ship. It disappears bottom first. That can only happen on a globe. That's wrong.
How is it wrong?
Because we can demonstrate it on a flat surface.
And my question to you would be, do you mean the flat surface is bent, and do you mean like this?
No, no curved flat surface, just a flat surface.
And where did you prove this?
Side chat.
It's been done on lakes.
On lakes, okay.
On a lake, right? So if you take a lake, right? So the horizon's supposed to be what you think is the curve of the Earth, where the curve starts. The ships sail over, right?
Yeah.
So if we take a small lake that's only 1,000 feet long. Now, should there be a horizon on a lake that's 1,000 feet long?
I don't know. Maybe
1,000 feet.
Yeah.
You think the curve of the Earth starts from 1,000 feet?
How much is 1,000 feet in meters? I'm not familiar.
I don't know. 330 meters.
I wouldn't say so. In 330 meters, I wouldn't say so.
Okay. So these tests have been done on 1,000 foot on a 330 meter lake. Okay. Take a little boat, sail it across, dude, and it disappears bottom up. According to the globe, the horizon should be 2,600 feet away, which is, I don't know, 3 into 2,600, 700 meters. That's where the horizon should be, 700 meters away. But the boat disappears in 150 meters. Okay, so we know, we know that this lake, at least for the 1,000 feet, is flat.
Yeah.
And we can get the exact same identical visual effect.
Well, this is interesting. So it might be not good proof of them. Yeah. But there are also another
point was the Earth, that water that they observe a ship going over the horizon, that water's flat, right? The horizon is flat, right?
Yeah.
So that's what they saw. They saw flat horizon, they saw flat water. That's why I said we've all observed the flat Earth.
Yeah, but why would they see the tip of the ship first? Just because the horizon is flat. This doesn't make sense to me.
It doesn't matter whether it makes sense. That's what happens.
So you're just saying
I can explain the answer I can explain why it happens, but you won't understand the answer.
Okay. Is it too complicated?
You won't.
Or is it
well, I mean, because the horizon's not a physical edge of a ball. The horizon moves around day to day, hour to hour. I could go out right at noon and say there was a buoy out there in the water, and it's 5 kilometers away, and I see the buoy right on the horizon. I could come back 2 hours later, and the horizon is past the buoy, and then I could come back an hour later, and then the horizon is in front of the buoy. So the horizon is not the edge of the ball; it moves around.
Yeah.
The horizon is an optical effect. It's created by optics. It's not created by geometry.
Yeah. But if the horizon is very far away, you would still see the effects of a round Earth, you know?
Well, the horizon can't be the edge of that round Earth.
If it's really far away, it could be.
How would it move around?
Yeah, well, you said yourself that the horizon moves around, and if it's really far away, and the Earth
ball doesn't get bigger and smaller.
Okay, so if the horizon is the geometric end that you can see on a ball, If the horizon distance changes, that means the size of the ball would have to change.
No, but but I'm not arguing that the horizon is a geometrical, the thing.
Then
you
what's
said,
the ship
a geometrical.
disappearing behind?
Yeah, I'm saying I also like the horizon is an optical thing you see. But if the horizon
Okay,
is really
open the
far
flat
away,
Earth.
you would also see the Earth being round.
What are you
If it's
talking
really
about?
far.
Is the horizon the edge of the ball?
No.
Then how did the Greeks know that the Earth was observe the Earth was a ball by
That's
seeing
what
a
you said
ship?
yourself.
If the
You said
ship
yourself,
disappeared behind a horizon, that's optical.
like you said yourself that the horizon is only
That's
also
right.
moves. Yeah. So you can things that appear are a lot. Yeah, and
Yeah. Hey, Fugazi, do you understand that you said that ships going over the horizon was because of Earth curve? That's where you started. Now you're at ships disappear over the horizon because the horizon is some sort of optical effect.
like the horizon is an optical effect because like the air, like it, yeah.
So what does ships disappear behind?
The horizon.
And what is that?
Is it the curve of the Earth?
Like it's when I don't know really how the horizon really why there's no horizon, but I would assume
We know.
that I would assume that it's just air, the layers of air are stacking on top of each other, and then some light always bounces off this air, and there's maybe some molecules or other things that affect this effect, and that's why this happens. This doesn't have to be like the end of the Earth. Yeah, I would also agree on
when
that.
you say a ship goes behind it,
Yeah.
down around the ball, if the horizon is optically created, that cannot be true. Okay, that's why we said sometimes this is observed. Okay, in fact, but it's not observed all the time, and it would be observed all the time if it was the geometric edge of a ball. I've seen a ship sail from 6 miles to 30 miles. Now the ship should have started disappearing behind the horizon at 4 miles.
Okay.
But I can see it for 30 miles, never disappearing.
Yeah, so okay. So you say that you cannot see these effects yourself when you do the experiment yourself, right?
No, you can't either. You just never
the
tried.
meteorological conditions of the day dictate what you see. It has nothing to do with the geometry of the Earth. I could go out on one day and see one thing. I can go out on another day and see another thing.
Okay. Yeah, and
but every day I go out, the water and the horizon are both flat. The only thing that's going to change is where that horizon appears to be. It'll be closer, it'll be farther away.
Yeah. But like this thing I said before was if my question, it would also be a question. Like what would happen if like the horizon was really further like very, very far away from your
How far?
point of observation? Like like 60 miles, you can see you would be able to see the curvature of the Earth if the Earth was round. All right?
He doesn't
Yeah.
understand. The horizon is
60
supposed
miles-
to be the limiting factor.
Yeah.
So what if I'm like 3 feet, 1 meter off the ground, and the horizon's 50 kilometers away?
Yeah.
Yeah. So the horizon from 3 feet off the ground is supposed to be 2 kilometers away, not 50.
Yeah, I don't really know these things, but my question just would be,
We do.
Is
That's
there-
why we're telling you.
We know you don't know.
yeah. But would like if the horizon is really far away, would you be able to see the geometrical
You-
curvature of the Earth?
How would you be
No.
able to see that?
Because you said that
You're not listening.
There is no geometric curve of the Earth to see.
The
Yeah, why is it
horizon at 1 meter high.
Listen, we can tell. Listen. There's a formula for calculating where the horizon should be on the globe. It's 1.22 miles times the square root of the observer's height in feet. So you get the height of the observer in feet, multiply it times the 1.22 miles, right? Multiply the square root of that height. So if it's 9 feet, square root of 9 feet is 3, right? So you multiply that with 1.22. So at 9 feet, the horizon should be 3.6 miles away.
Okay.
Yeah.
Okay. So if I go out and it's supposed to be 3.6 miles away, and I see it 30 miles away, if I see the horizon 30 miles, then no, I'm talking about the geometric horizon should be that far.
Yeah.
But we see a horizon way farther than that, 10 times farther than that.
Oh,
That's why we're here. Why do you think we're here? We're here because they told us the Earth is a globe. Okay, we went and checked. We found out that that can't possibly be true because the observations contradict that claim.
Okay, yeah. So
which is where we all started with this, right? This is where this started. What Jimmy Will said, right? He said, "You go out and measure it yourself," and he said, "Once you do, you'll be a flat earther," because he knows he's not afraid that if you go test the globe yourself, you're going to find out that it's not a globe and can't be.
So you measured it yourself, like you took a boat and you measured.
Well, yeah, there's a website called marinetraffic.com where you can track ships. So I went to the beach and I tracked the ship going out to sea.
Okay.
And I can see it for 30 miles, which is 50 kilometers roughly.
Yeah, but did you see the light or did you really, it was a day?
It was daytime.
Okay. Like, this would be very interesting to see, like, if you would be able to see.
Well, the ship should be under the horizon completely. It should start vanishing at 6 miles. And at 30 miles, you still see it. Think about it.
Yeah, but you also calculated that you shouldn't possibly be able to see this boat, right?
Yeah, because we're testing the globe claim.
It's based on the circumference of the Earth and the radius.
Before you did your experiment, you calculated that you were not possible. There was no possibility that you would be able to see this boat, right?
No, what I did was I did the observation. I took screenshots. I filmed it with my camera. Took pictures. Then when I got home, I analyzed the video and said, "Hey, from this distance, from my observer height, where's the horizon? Should I be able to see this ship?"
You also knew the height of the ship, right? You also knew the height of the ship.
Well, I know look, it should be 420 feet under the horizon. The tallest ship in the world is 280 feet. I know it's not the tallest ship in the world. Okay, so it doesn't matter. I don't need to know the height of the ship because no ship is that tall.
Okay, and you also knew the spot where you stood, right?
Yes,
you took.
I know the elevation. Yes.
Okay. Like this would be interesting if all the people that would measure this themselves would find out that the Earth is flat. Like I would find this very interesting, because
that's what we tell people though. We tell people don't trust us, don't trust NASA.
I would measure it myself.
It's a simple test. That's why we tell it. Like this is 3rd grade geometry in a simple test. It's simple.
I like this idea of measuring it yourself. I really like this idea because, like, oftentimes we take things for granted. Yeah, I like this idea, but I don't think
something I ask people all the time in this topic is, if nobody told you the Earth was a globe, would you have figured it out on your own?
I don't think so. I don't really think so.
Everybody says what you say. No, I would have never thought of it. I would have never figured it out on my own.
Yeah.
So they're basically admitting this idea comes externally from somebody else. Somebody told me the Earth's the globe. That I don't know it is. I heard it and I believed what I was told. And we're here telling everybody, hey, we know what you were told. We were told the same thing. But we went out and tested it. We checked. We did the fact check or whatever you want to call it. And the fact is, it's not a globe.
Yeah.
Do you know what got me into flat Earth? What sparked this for me? So on TV, there was a television weather report, and they showed a picture that one of the viewers had taken. It was of the Chicago skyline from 52 miles away, which is, I don't know, 70 kilometers, whatever, right? Well, it shouldn't be visible.
Yeah. And why shouldn't it be
And I
visible?
was like, and he said, this has to be a mirage. And I'm like, whoa, that can't be a mirage because mirages are double images. So I'm wondering why this meteorologist is saying that, why he's saying something which is obviously not true. And that just led me down the path. And it comes to find out people have been seeing this Chicago from all the way across Lake Michigan for 80 fucking years. And nobody ever thinks anything of it because they think, well, it's just a giant globe. I should be able to see Chicago. It never crosses their mind that they're viewing something which breaks the globe. They just never even think of it.
Yeah, but I also would think like many physics and like many things you can also calculate yourself are based on the assumption that the Earth is flat, and there also work. So yeah, that's why I would think that the Earth is like
Well, the shape of the Earth or the surface feature of the Earth, whether it's curved or flat, that's not a physics question.
Yeah, of course it is. Like
It's just
you have
math.
the gravity. Yeah, but you have gravity, and you can then calculate the gravity.
What's gravity?
Of the sun. Yeah, the gravity is
What's
a force.
gravity?
And you can.
How do you know that gravity is a force?
Yeah, like you cannot. You are. So you are when you jump up, you go down back again. So it's a force.
Okay, so that's gravity.
Yeah.
So it's just a calculation of acceleration. That's it.
Yeah. Yeah.
Has what it is, nobody knows. It's just acceleration.
Yeah. Yeah.
Okay.
Yeah. And
All right, that doesn't make the Earth a ball.
Yeah, but then you can calculate like the gravity of the sun. You can calculate the gravity of the moon, and then you can
No,
calculate where the
that.
moon and the sun is. And then it would also really make sense that the Earth is also flat.
You can't calculate it
Yeah,
using the acceleration on Earth. You can't calculate the gravity of the sun.
You can.
No, you can't.
You can calculate.
You're confusing big G with little g, dude. They're two different things.
Like you can calculate how if the gravity of the Earth is because of the mass.
Can we agree that if the Earth is flat, then whatever gravity is, it's not making the Earth a ball?
Why? Even though it's a perfect sphere?
It's as close. If the Earth is a ball, it would be as close to a sphere, a perfect sphere, as you could possibly get. They say that the diameter across the equator and the diameter across the North and South Pole is only a difference of 26 miles, and that's over 8,000 miles. So it's about as close to a perfect sphere as you're going to get.
Exactly, considering the gravitation in the center.
All right. So then where? So if you're 1.8 meters tall, how far away is the horizon when you stand at the water?
When I stand at the water, how far?
Yeah. Yeah. How far is the horizon?
I don't know. Horizon defined by the point that you can see, or the view, as far as you can see.
Well, when boats go over the curve,
Yes.
how far away is that?
I have no idea. I don't want to guess either. Why don't
Well,
you?
then
Why
would you assume that it's the curve of the Earth? If you don't know and you don't want to guess.
I don't want to get into this, actually. I know how it ends.
Is it hurting your brain?
No, it's actually interesting, this theory. Because I think, why would people, what have they to gain from hiding it? What is their secret? How
They're
are
not
they?
hiding it. They're not hiding it.
They
Who
just
says
don't
they're
know
hiding?
you.
I just presented you with a story.
You're choosing to believe us. You're choosing to believe one story.
I don't
You were
know.
taught a story, and you're choosing to believe it.
It's not a story. It's I don't. Basically.
It is a
You don't have any
story.
evidence.
But why? So all
Because
the moon landing.
you're gullible,
all the-
man. That's why you're believing it. You're gullible.
Most people believe it for the same reasons you believe it. They were told it, and they've just
Yeah.
accepted it, right? I used to believe it. Sheepdog used to believe it. Everyone in here that's a flat earther used to believe in the globe, right? We accepted the
all
story.
around the world.
Yeah, but it's just like, do you think your teachers that taught you the Earth is a globe, you think they actually knew anything? Think they ever did any tests or experiments?
Right.
You think your college professors that taught them the Earth is a globe gave them any
They only
experiment?
told us the basics, like Columbus.
Yeah, but did they do any experiments?
And the
The
horizon.
stories are great, but science is decided by experiment. It's not decided by but the explanation. So no matter what your explanation is, such as the theory that gravity would form the Earth into a ball, that's fine. That's a great theory, but you would actually need to demonstrate it by experiment to call it scientific, right? You would actually need to go, if your theory was, hey, gravity forms the Earth into the ball, you would need an observation of that happening to call it scientific. Science
So if you
is
go
the
to
arbiter
zero
of
gravity,
science, the arbiter of the
cold
truth of a
water,
scientific.
forms
Listen,
into a
brother,
sphere.
this is very important. This is very important. The arbiter of the truth of a scientific claim is experiment. That is it.
Yeah. Occam's razor also. It's the most simple answer.
Occam's razor is
usually the
philosophy.
right one.
Yeah,
Ah.
you want Occam's razor with flat Earth? The Earth looks flat because it is flat. There, Occam's razor. No assumptions.
I
Oh, it
got a
looks flat,
question.
but you can't
I
trust
think
your own
quite
senses.
the
It's really a
psychology
ball.
of Earth
Can I ask you
or flat
something?
Earth was interesting. I don't know.
Indio?
Yeah.
Can I ask you something, Indio?
Yeah, of course. Shoot.
If
I think he's trying to ask
other
Indio a
if
question.
What,
if
Gabriel?
other planets are globes, why this is an exception? Why this is flat and other planets are globes? Because you can see with
Because the Earth isn't
a
in other
telescope,
planets.
you can
You
see
asked me a
with a
question. Can I
telescope
answer?
that other planets are globes. Even in
Okay.
this galaxy, on any other galaxy, all of them are globes. But why this is the unique planet that is flat?
Earth isn't a planet. Where did you
This
get the
is not
idea
a
Earth is a
planet,
planet? Hold
and
on.
other are
You're putting the
planets.
cart in front of the horse, Gabriel. Where did you get the idea Earth was a planet?
From school, I guess.
Yes, because
Have you ever observed Earth to be a planet?
Not really.
Yes, this is a planet. This is a planet.
Yeah, how do you know
As
that?
any
How do you
other,
know Earth is a planet, Gabriel?
because it's the same as others.
How do you
And
know?
others
No,
are
no.
planet.
Okay, it's the same. So there we go. There's the crux of the matter. Good. I'm glad you said it. So that is philosophical. That comes from the Copernican principle invented by Nicholas Copernicus. That Earth
Yeah.
has no unique position in the universe. And if you take that philosophical, because you can't prove that, right? Whether the Earth's unique or not, all evidence points to that the Earth is unique. It's the only place with life. It's the only place with liquid water. It's the only place with lots of things that we can observe.
But
So it
there
is
are
unique.
other planets that
So what do you
has
think
How do you
about
explain the gravity?
water.
8%?
This
Oh
is
my
not the
God.
unique planet with water. This is
It's
not
not a planet.
the only
It's
planet
just
with
unique in every
water.
sense. It's not a planet, okay? It's not in the category planet. So planet is a category of object. So can you tell me what you have observed about the Earth that would place it in that category of planet?
When did you see that this is
Why are
not
you
a
asking me a
planet?
question? Why
When
don't you
did
just
you
answer
see
my
that?
question? Answer my question, please.
Could you repeat that, please?
Yeah, that's what I thought. What
He
have you
can.
observed about the Earth that would put it in the category planet? If I go outside, I look around, why would I say the Earth is a planet?
Because it is. Even if
Yeah, but
you
why?
call it,
This
even if
question,
you
why?
call it
How did
as
you
a
come to
planet,
this
I'm
conclusion?
convinced.
Not
even
an
if you call
answer.
it
Because
as
it
a
is.
Earth, even if you name it as an Earth, is a planet.
How do you know it's a planet? What is the
Because it's
evidence?
because it's like the third or fourth planet in the galaxy,
How do you
like
Jesus
every
fucking
other
Hogwarts
Christ,
planet.
circular
bro.
reasoning.
Yeah,
So
dude, listen.
why this is
I'm
an
asking you how
exception?
you know that. What is the evidence for what you're saying?
I'm going to Google it.
They
Wait.
didn't give you any
Oh,
evidence.
okay.
That's the
No, you're
thing.
not. We're not doing it. Go on, fucking mute, bro.
Okay. Brother, tell me the
Ash,
definition of
go
planet.
ahead, Ash. I'd rather deal with you.
Just tell me the
The
definition of
definition
planet.
of a planet is
And then
a
because I said
celestial
so.
body.
Jesus Christ.
The definition of a planet is celestial body. So when I look up in the sky, I don't see the Earth. So how is the Earth a planet?
Okay, the definition of planet is a celestial body, right?
Yeah.
Right. So the Earth is celestial, meaning
Asteroid.
that it's in the sky. The Earth is not in the sky.
So you mean that asteroid is also a planet?
What? No.
Asteroid is also
No,
celestial.
dude. Celestial means in the sky, right? Up there, there's terrestrial, Earth, and celestial,
Mhm.
not Earth.
So do you mean that stars are also a planet?
No, planet is the definition was wandering star. So it's the stars that move different than all the other background stars.
No, then what's the definition between like star? Star is also celestial?
Stars are fixed.
Star is what?
They all move fixed relative to each other. The ones that don't, the ones that move different are called planets. This all comes from the Greek. But the thing is, what makes you think Earth is one of those? Jesus Christ, Gabriel.
So how are you classify the
Hold
Earth
on.
is not a
Hold
planet?
on.
He's fixed.
Hmm?
Gabriel's having a
Just hold
meltdown.
on. Somebody's getting banned. Just wait a minute.
He said, I mute people when I don't know the answer. No, you got muted because I'm not debating Google.
No, you're not debating the Google. Just tell me the
No,
definition.
Hold
talk about,
on, Ash. Be quiet
Ash,
for just a minute.
talk about Gabriel, Ash. Gabriel, not you.
Okay, I understand.
You look, bro. I can tell you're hardly paying attention to what's being said to you. So pay attention.
Yeah, he's probably reading from Chat GPT also.
Yeah.
Ash, are you typing things in the Chat GPT?
I'm not even typing.
No, not right now. But I mean, is this what your plan is? We're going to answer questions, and then you're going to type things in the Chat GPT.
Nah. I don't use ChatGPT by the way.
So did you notice the thing I asked him for, Ash? I asked Gabriel. I asked him for evidence. So us here, we're concerned with evidence. We know the claims. We know the claim that Earth is a planet. We know the claim. We know all the claims. We want the evidence for the claims. What's the evidence that that claim that Earth is a planet is actually true? And evidence would be the form of observation, experiment, something. I've never observed the Earth to be a planet. You've never observed the Earth to be a planet. Sheepdog has never observed the Earth to be a planet. So how do we know that that claim that Earth is a planet is true?
So what's Earth? Like how do you explain the Earth?
Oh my gosh.
How do I explain the Earth? What do you mean? What does that even mean?
I'm just trying to
He asked,
know your viewpoint.
Someone please help.
dude, you asked, what is the Earth? So
What's underneath your feet? Is that, what do you call that? This place that we live.
You said explain the Earth.
Yeah, jeez.
Like, give me a definition of Earth according to you.
Terra firma,
Oh my
underneath
gosh.
your feet, bro. You're standing on it, including the water in the ocean. Do you disagree with that? Disagree with that, Ash? That Earth is the ground under your feet? And Fugazi's deafened and muted, but he's in the text chat. What the hell? God damn, what'd you guys do to him? He was seemingly civil in here, and now he's spazzing out in the text chat.
About gravity, he disagrees with Einstein, I guess. That's okay, though. He can disagree with Einstein if he wants to support Newtonian mechanics.
I just want to know how he got fucking the gravitational pull of the sun from dropping something.
What?
Dude said you can drop something, measure its acceleration, and get the gravitational pull of the sun from that.
Yeah, like okay. So yeah, this is
That's
maybe.
cool, bro. The idea that you can get the gravitational pull of the sun from dropping a freaking brick on Earth is just it's so out of it. Look, brother.
Yeah, I would. Yeah, maybe that doesn't work because like the sun has a different density than the Earth would have. So yeah, you're right. But the thing I just wanted to say is that gravitational forces are real forces, and it's the only thing you can say and you can measure yourself. But this is not an argument about the Earth being round or flat.
What?
Yeah.
Okay, hold on, Fugazi. T-Dub was telling you in modern science, gravity is not a force, and it hasn't been a force for 100 years. In Einstein's theory of relativity, gravity is not a force.
Yeah, in Einstein's theory of relativity, he talks about little things. He doesn't talk about big things. He talks about electrons. He talks about protons.
No, he's about the bending of space-time and black holes and all that shit.
Things. He talks about fast things that are at the speed of light. He doesn't talk about things that are just,
Einstein's theory of general relativity is a theory of gravity.
Gravity, like no.
Where do you think the idea of black holes come from? It's the Schwarzschild solution. Listen, brother. Black holes, right? Black holes come from the reason they thought black holes exist is there's something called the Schwarzschild solution to general relativity. Okay? It's Schwarzschild's limiting thing where the smallest radius you can have where you have basically a collapsing fucking mass. Okay?
Yeah.
That is in the Einstein's theory of relativity. It's a gravitational theory. Yeah. You're talking about the theory of special relativity, which is different. I'm talking about general relativity.
I don't know what you call what are these names, but I can just tell you the theory of like you said general gravitational. I don't know general relativity. I don't know. Yeah, this is general relativity, but I talk about like the thing, the force that is pulling you.
No forces in general relativity. There's no forces.
Yeah.
There's no forces.
But I talk. Yeah.
Want me to post citations, Fugazi? I'll post citations from academic sources, okay? It says gravity is not a force.
Yeah, it's okay. But like the thing you can observe yourself. You can observe yourself that the gravity is a force. You can observe it yourself. You don't have. You
I've
don't
never
need
seen
those
it.
academics.
How do you observe it? What is
so,
a force? What is a force, buddy? Is he breaking up for you too?
Yeah, he's a robot.
My mic broke away. My mic broke away. So the thing I wanted to say is you can observe gravity as a force yourself, because if you jump up, you are being pulled down, and it doesn't matter what Einstein. Okay, and how is it wrong? Explain.
How does that make
explain
that in Einstein's theory?
I don't talk
The
about
Earth
Einstein.
would be accelerating
Einstein,
up to you. In Einstein's theory, the Earth would
I
be
don't talk about
accelerating up to
Einstein.
you. There would be no force. It would be the contraction. It would be the lowest
Yeah.
energy geodesic using the principle of least action, which made you fall down, not a force.
Yeah. Okay. Okay. All right. All right. I
So
don't
look
talk
in the
about
side
Einstein.
chat. I just posted 5 citations from academic sources.
Why do you need Einstein
Gravity
for
is
this?
not a force, Fugazi. You're not
This is
arguing with
not-
us. Fugazi, you're not arguing with us. You're arguing with all of academia.
Yeah, but like you don't need Einstein. You don't need Einstein. You don't need these academics to understand like basic physics. Like, okay, I understand you
Okay,
talk about
Fugazi.
Yeah.
Listen to this. I let my pen go, it goes down.
Yes.
Outside of witnessing it go down, outside of measuring how long it takes for it to go down, what is the cause?
Like we have a name for this. We have a name.
Yeah,
Physics
that's
has a name for
excellent.
this, and it's
Hey,
called
listen
gravity.
carefully. Whoa, slow down.
Gravity.
You're getting excited, son. Listen carefully. Science, to date, does not know what the causational mechanism of down is.
Yes, exactly. Yeah, and I don't even argue this. Like this is known. Everybody knows this. Who knows a bit of physics? Like this is not. We don't.
You
know
didn't
what
listen to what I
gravity
said. If science to date does not know what the causational mechanism is, how come you're still blurting the word gravity out?
Because it is a description for this relationship. Okay.
So it's not a force then.
The relationship between what?
Of course, it is between the thing you pulled up and it went down. It was pulled down back again. Like it's the same force.
Pulling is a force.
Pull down.
Yes.
So I'm just going to read out what AI, Google's AI mode says when you ask it to describe Einstein's theory of gravity.
Yeah,
He
but
says
like this,
Einstein.
this
Einstein.
doesn't have to do
Listen.
anything with Einstein.
Yes,
doesn't
this
have
is
to
what
do
this is the mainstream rhetoric. Okay, look, that's the
The
mainstream
This
rhetoric.
is not mainstream. Like this is
Yes, this is mainstream. This is mainstream.
Yeah, but this.
Are you going with something that's different to that? So this is what
No.
they're teaching people.
Just
This
said
is what they're
Einstein
teaching
ain't
people in
mainstream.
universities.
Jesus Christ.
Yeah, of course it's mainstream, but like
Right.
this has to do about like big.
No, this has to do with why motion occur. Motion of physical objects occurs. This is why. This is what they're teaching people. Are you disagreeing with that? It's okay if you do. It just means you have to support your own position on it. One that is not a consensus. That's all.
Okay. I meant something different. I meant
right.
So, you talked about general relativity, all right? Like the theory of general. I don't know how it's exactly called in English, but yeah, you talked
doing
about
it
this,
fine.
right? Huh?
You're fine. General relativity. You're good.
Yeah. Okay. And like I know these formulas that Einstein said only work if you have like very high, if you're very fast, or you have very high masses, or you have anything different than this. Okay, this doesn't apply to basic physics. You can see
Okay, Fugazi.
Yeah.
So let's just say I've got a ball that weighs 1 kilo, right? That falls under Newtonian gravity, but as soon as it becomes bigger, so what's the threshold? At what point does it switch gravities? See how stupid your statement is now when you've just realized that you've got to contend with two different ones?
Look, the difference between them is
I will reply to you in a minute.
What you said was partially correct. You don't need to do what's called a gamma correction for the Lorentz contraction until you get into large mass or high acceleration. You don't. It's not necessary. Okay. So what they do is they linearize Einstein's field equations in the what's called the weak limit. That means below these high accelerations and these high masses. And they're mathematically equivalent to Newton's theory, but the causal mechanism is not a force. It's the geometry of space-time. There's no forces in Einstein. In fact, mass is defined as resistance to acceleration. It's not even defined the same. But that's all fine and dandy because it has nothing to do with dropping something. Okay? You're conflating two different ideas. Little g, which is the acceleration of an object falling on Earth, which we know empirically from measuring it. Outside of theory, we knew that before Newton even came along. We could measure the 9.8 meters per second squared. We don't need any theory to know that. Now, the claim that it's a force that's causing it and some pull toward the Earth, that's a theory. That's Newton's theory, okay? Which is not. Shit, dude. I got. How much of that got missed?
Only about 1 second.
Oh, okay, cool. So Newton's came from a geometric relationship, and it's not based upon any type of experiment. The point is you can't get the gravity of the sun from dropping something on Earth. We know the speed of that acceleration just from measuring it. See, this is the problem with gravity that we always get into when we talk about this, is that the way they teach it has turned people's mind into mush. They don't tell people that there's a distinction between the little g and the big G, in that there's that the little g is just known from measuring it, right? We just know it from measuring, like we can just measure it. We don't need a theory to know what it is. Now, when you start saying, hey, that little g, that falling, that's caused by mass attracting mass. And that's what makes the moon orbit the Earth and the Earth orbit the sun. And that gives the sun a gravitational pull. All that shit is hypothesis and theory. Okay?
Yeah.
Yeah, all that's completely different than the little g.
Yeah, but I have a question. Because you can measure, like, the gravitational pull of the Earth. You can measure this, and you can say,
Really?
yeah, like this. Yeah.
How?
I can measure it right now. What?
How?
Yeah, I put my pen a few centimeters above my table, for example, and then I measure the time it takes to be back at my table. Let it go. And that's how I'm able to calculate the gravitational pull.
Okay. Can you tell us how you're calculating that from the time?
Man, this is just
I want you to tell us, explain it to us, how you're calculating that from the rate of fall.
So, I have a question.
So you're going to use Newton's second law, right? So you're going to use Newton's second law. You have the mass of the pen, right?
Yeah.
But the force required to accelerate the force required to accelerate the object is dependent on the mass. That way, you drop a mass and you drop a bowling ball, and they both fall at the same rate. So it's just canceling out It's canceling out anyway.
What's canceling out?
Because the force required to dude, the second mass, the Earth, is canceling out.
What is it canceling out?
Okay, because the force required to accelerate the pen has a mass.
Yeah.
But because it has a mass, it takes a certain amount of force to accelerate it to 9.8 meters per second squared.
Yeah.
Right?
Yeah.
Needs a certain force. What if I take an object with a larger mass?
It takes the
like
same time.
Like a bowling ball or a freaking car or an airplane.
Yeah, it takes the same
And I drop that. Well, it takes more force to accelerate the airplane, right?
Yeah, of course, yes.
Because the plane has more mass.
Yeah.
Where's the extra force coming from?
Bro, do you know it?
I'm asking you.
Why are you asking me? Like this
because
is just,
when we do the
this is just
measurement,
what we see.
no matter what
This
we
is just
drop,
what we see.
it falls at 9.8 meters per second squared.
Yeah.
Okay. Yeah, that's independent of the Earth, dude. You cannot do any experiment.
Like
brother. You cannot do
This
any
is ridiculous.
experiment which will show you that the Earth is causing that.
Yeah, but oh god, oh, this is just okay.
There's no experiment you can do, because to do this experiment, right, you would need your independent variable. Your dependent variable would be your effect. You're dropping the pen and measuring its acceleration. That's the observed natural phenomenon, the effect. To figure out the cause of that, you need an independent variable, which you would vary and manipulate. Okay, so we manipulated the masses. Hold on, we manipulated the masses. We used a bowling ball or an airplane or something else versus a pen, but it fell at the same rate. So your manipulation of the variable didn't change the fact, which means that's not the cause.
So no, it doesn't say anything about
Repeat
the
back
cause.
to me what I just said to you, Fugazi.
I just want to tell you the only thing.
Yeah, you didn't listen to a fucking word that was said.
Yeah, if you would listen to me, you would understand what I mean, because you don't know what I mean and you're just mad. And this doesn't make any sense.
There's a way in science you figure out the cause of an effect.
Yeah,
in science.
But I want to say, can I say something? Can I have a word, please?
Yeah, go ahead. Try and pull more smoke up our ass.
The only thing you would observe in this experiment is that the force on an object with a certain mass is
that's the thing you're trying to prove. You're trying to presuppose the conclusion, dude.
So but
you haven't demonstrated there's a force.
So you say I haven't demonstrated that it's a force. Okay, so why does the pen go back?
Why are you asking me a question? Demonstrate it's a force.
Okay, so what is a force? Do you know what a force is? Do you know what a force is?
Yeah, a fictitious concept.
Okay, so like this is just ridiculous what you think. I just really like this is just basic
ridiculous
physics.
What I think.
I know. I understand what you mean. Like I understand what you mean. I guess okay. Yeah, okay.
You don't know how to do an experiment to figure out the cause of an effect, dude.
Can I just have a word? Okay, maybe the Earth is not round. Okay, maybe the Earth is flat. But to argue like basic physics is just ridiculous.
You don't know any basic physics, Fugazi. You don't know any basic physics.
Like it's just hard to me explain. It's just hard to me explain for me to explain in English, because like it's not my native language. If you would give me some time, you know what
an independent variable is?
Yeah, of course I know. Of course I know.
Independent variable is.
Yeah.
Now, how do you figure out the cause? The phenomenon that's causing a change in the dependent variable?
You change a variable.
Hold on. Hold on, dude. You manipulate the independent variable, right?
The independent or the dependent? Is it right? You said
the dependent variable in this case would be the falling object.
Yes, of course, yes.
So how do we? Look, bro. How do we manipulate the cause of that in such a way we can determine what the cause is?
We're not able to.
Oh, there we go. So you're saying it requires a force, dude. You just admitted that you don't know that because you can't do the experiment.
We can observe a force, but we cannot explain why the force exists.
You're not observing a force, dude. You're observing a force.
I can predict it.
Fucking object.
I can prove to you that we know that there's a force because we can predict.
What color is the force?
Eh?
What color is it?
Because it doesn't matter. Like, why does the force need a color? What are you talking about?
Because we need an observed phenomenon, dude. What? Okay. I mean, I don't know where else to go with this.
Yeah, I really try to listen to you and understand to you. Like, I'm not mad at you or anything. I'm just trying to understand what you say. But
Fugazi, the reason you're trying to understand is because you've been taught a very particular set of things at school.
I'm not being told anything, all right? You don't know anything.
So you don't. So here's you trying to tell us about physics, but yet you don't know anything about physics. So which one is it? Do you know about it or not?
Fugazi, how do you know that the reason an object falls is because of a force.
Because that's the word we gave to this context. Okay? It's
So
not
instead
more,
of
it's
using
not
the
less.
word acceleration, we use another word called force.
Yeah. We just use
So it's just a different word.
It's just a word, yes. It's not
So it has
something
no
special, not
ontology.
something magic.
Great. So it has no ontology. It has no independent existence by itself.
What do you mean by that?
It means it has no. It doesn't really. Forces don't really exist. It's a placeholder for acceleration.
Conceptual.
It's
There's
a
a context you
placeholder
can
for.
describe with
God,
the
dude,
word.
all you do is fucking talk over. It's a
Yeah, you also do
placeholder
that, like-
word for acceleration and deceleration, right?
Multiply
just a word.
by the mass.
Yes,
Do forces actually exist physically?
What?
Do forces exist physically?
Yes, because it's a context. It's a word for a special context.
What are they made of then? What is a force made of then?
What is this question? What is a force
It must
made
be
of?
if it's physical,
It's
then it
just
should
a
be able to
model.
be
It's just a
measured.
model.
It's just a model.
Yes, of course, it's just a model.
So it doesn't.
Yes.
Right. So it doesn't necessarily exist physically in reality.
Yeah.
It's fictitious.
Okay, I understand what you mean now, and I understand what. Okay, yeah, it's true. Yeah, it doesn't exist. Basically, it doesn't exist.
It's fictitious.
Yes.
But
Yeah,
you said we can
basically.
determine it's a force by looking at it.
Yeah, we have a model for
What are we looking at?
this context. We have a model for this context, and on this model, based on this model, we can make predictions, and that's why it exists.
That's not how we do this. Yeah, but that's not how we predict how something falls. We know the rate that something falls empirically, meaning we measured it lots of times. That's how we know it. We don't know it from a model. We know it from experiment.
Yeah. And the experiment proves the model.
Brother.
And the experiment proves the
No,
model.
we know it independent of a model, brother. We knew 9.8 meters per second squared before any model, any theory of gravity ever existed.
No. Oh yeah.
Dude, you could literally not have any fucking thoughts in your head whatsoever. And take a fucking radar gun and measure the acceleration of a falling fucking object and know what it is.
Yeah, but
you don't need to know anything.
Yeah.
Yeah, that's all we're pointing out. Little g, is known empirically from experiment.
Yeah.
In fact, they even voted on what the value is. Literally voted. Okay. It's even the laws in some countries, even in the laws of some countries. So
because
the point is that is known empirically. It's like a law of nature. It just happens. Now, the other stuff that comes behind it, what causes it? Why does it happen? Is it a pull? Is it a push? Is it entropy? Is it the bending of space-time? All those are theories. But none of them you can't do the experiment, as you admitted, required to determine whether a falling object, that's the reason why the object falls. We can hypothesize and come up with a model and incorporate that falling into the model, which they've done with Newtonian gravity, right? They've said, well, if something falls at 9.8 meters per second squared and the Earth has a radius of 3,959 miles, then we can infer from the inverse square law that the Earth has such and such a mass, right? We can do that.
That's not what I'm
incorporate it in there, but we don't know that that's the reason.
Yeah, but it really makes sense if you look at it, because like the moon.
Lots of things make sense, dude. Making sense is no standard.
Yeah, but like the moon also has like this gravitational pull, and like the Earth, the moon is.
These are claims. These are claims, dude, that you're making. Once again, you've gone back into the thing that you told us earlier that you take for granted. Everything that you're telling us right now, you've only taken for granted. You have no evidence of the things that you're saying.
Yeah, but I can see there are just. I understand what I mean and what you mean, and in some sense you're right, because like it's better to not take everything for granted, but also sometimes it's just better to just follow these models and to follow everything, Because maybe you will end up in a point where you understand more than you would be able to understand if you don't follow these models.
Well, let's see if it's true.
I would make.
Let's see if it's true. Let's see if these models that you're describing are only conceptual. You have to remember that. And let's see if they hold. Let's see if they hold any water. So let's look at the model. Okay, so according to the model, would you agree that everything falls in a vacuum at 9.8 meters per second?
No.
You wouldn't agree with that.
Yeah, I wouldn't agree with that because like the Earth has just some points of the Earth are bigger, so there's more mass attracting it, and there's some places where the Earth is a bit smaller, and so it's not a constant for the whole of the Earth. Yes.
Okay, so what about the things that go upwards?
What goes upwards?
Well, let's take for instance gas. Gas moves freely and randomly in all directions.
Right.
Okay, so where's gravity all of a sudden? Now all of a sudden the gas is going everywhere. It's not going down at all.
Because the density of the gas you talked about is less than the density of the air. So it goes up. Like
dude, gas and air are the same thing. Air is gas.
No. Yeah, okay. Yes. I don't know which gases. I don't know which gases you talked about. Like
all of them.
Gas. I don't know. I don't know which gases.
All of them. All of the gases go freely and randomly in all directions. All of them.
Because the density is smaller than the density of air.
Gas is air. Air is gas. All of them go freely and randomly in all directions. Okay. So what happened to gravity?
Yeah, I just explained to you because the density of these things you talked about is smaller than the density of air.
Air is gas.
Yeah, but what does it have to do with gas? Okay, what does it have to do?
Dude, you're telling me that some places on the Earth things go down at a different rate than other places. Yeah. And now I'm giving you an example of gas being molecules moving freely and randomly in all directions everywhere on Earth. This is what they do.
Freely and randomly?
Yes, this is physics. This is known. And you're saying gas is less dense than gas, which doesn't make any sense.
So you say they go these gases go also up, right?
Yes.
That's what you said. Yeah.
Yes.
And my argument for that would be because the density of the gas you talked about, and it doesn't matter that air is also a dense.
You're not even answering. You're not answering the question. You're saying gas is different than gas. The density of gas is different than gas. That makes no sense.
I have a question to you. Is the density of every single gas the same?
The density of it? That's a good question. I don't really know.
Yeah, because it's not.
It depends actually on the energy state more than anything, to be honest with you.
Yeah, but the density of every gas is not the same. Yeah, it depends
okay, well,
on the energy
could you
state.
show me how you would prove that?
What?
What you just said, that the density of gas is not all the same.
Because some gases go up, some gases go down. Like
that's not true. It's a homogeneous mixture.
Yeah. This is hard to make a homogeneous mixture. Is very hard. Like you cannot make this.
No, it's dude. What you're breathing right now is essentially nitrogen, CO2, and oxygen, and they're all mixed together. So they're homogenized. So there's no stratification of gases. So what you're claiming is incorrect.
Like that's an interesting claim.
It's not a claim. It's just what we observe. Where are the gases stratifying?
You didn't observe anything. You didn't observe the.
This is what we observe. I'm breathing the air. They've tested the gas.
CO2? Do you see the CO2?
No, you don't see any of it. It's called gas. It's impossible. Its angular size is too small. Don't you understand? Dude, why are you laughing at me? You're telling me gas is less dense than gas, and you're laughing at me?
Yeah, because not every single gas is the same.
In what context?
I guess that's it.
That is it. So there's no gravity because the gas is moving freely and randomly in all directions. The clouds They're maintaining their altitude most of the time in one place, unless there's a change in energy in the air, by the way, and they will go up or down, or they grow taller, or depending on, the density of the air. You can have two different layers of density of air, although it's still homogeneous, but one's warm, one's cool. One's above the other, one's below the other. And then they try to, equalize, and then they'll get in a big fight, and then you'll have a thunderstorm or wind. But none of that gas is actually falling to the earth. Gravity is something that you've taken for granted, just like the globe Earth. I'm sorry, someone gave you bad information.
So I just posted a citation from a paper that detailing studies of trapped gases in caves underground. Talks about how there's no heavy gas stratification, only a thermal gradation.
Yep.
Did that guy go away?
I guess he ran away.
Yeah. I'm glad you guys didn't let him succeed. He kept trying to characterize I just can't believe you guys don't understand the science that I read in my middle school science textbook glossary. Great job, everybody. Because every time he got pinned into the wall, he was trying to squirm out of it, so it's not surprising that he ran away.
Hey, did you hear the audio I played this morning?
Me?
Anybody? I don't know if any of you people are in here. I want to play this because it's so good. It's just awesome. I got this off of I got this off of I got it off of X, but I think it originally might have been on TikTok or something. But it's great. Listen to this crap. This is like a mainstream physicist. This isn't some crazy flat earther. Just give me 1 sec. I gotta play it in the bottom.
Man, what I thought if there was a flat earth or a sphere earth, it doesn't matter, because if there is no one to ask question or debate about things that are beyond our imagination or out of the box, this is also important.
That's right up. That's right where I'm. Listen, dude, you're right up my alley, man. That's exactly what I'm going to play. Is something about imagination.
So it's a good thing or bad thing?
Good thing.
To a point, it's a good thing. You don't want to imagine you're Superman and jump off a building. That's not.
No, not that kind of imagination, but imagination that can think out of the box, because there are things that humans are not capable of understanding, and eventually human discovered everything. So why not another man can discover anything else? We just say that he is stupid and he don't know about anything. We have facts about everything. He was talking about shit.
I agree, but everybody needs to hush up. I'm playing this audio, man. It's only like a minute or something. It's a minute long.
By the YouTube community here or what?
It makes me sad. And I don't just mean Star Trek. I mean any franchise that's about big spaceships flying around the galaxy. And I don't find it depressing for the reason you might think. I don't look at this and say, well, I wish I could go on adventures around the galaxy. I wish this stuff existed in my lifetime instead of the future. I find it depressing because when you go to look up, well, when will we have something like this? Interstellar travel, never. Allow me to explain. In any franchise like this, when they talk about how their ships work, it's always some kind of literal magic. It's a warp drive or hyperspace or wormholes. It all comes down to some kind of a magic portal that basically lets them skip the long distances. So they are effectively traveling many, many times the speed of light because they just go in here and pop out there. You need to understand that from a scientific perspective, this is no different from if in their engine room they just had a wizard with a magic wand. This is purely a plot convenience dreamed up by fiction writers. There is absolutely no scientific theoretical framework for ever being able to transport a spaceship around the cosmos this way. See, the issue is that because there are no shortcuts through space as there are in fiction, you have to distances, and the distances are much greater than the average person understands. For example, right now we are trying to go to Mars, and Mars, when it is at its closest to Earth, is about 35 million miles. That's doable at a cost of up to $500 billion, $500 billion. Because this thing doesn't just need to fly for tens of millions of miles, but it needs to be able to keep the astronauts alive for years. Everything has to work perfectly for years without any opportunity to stop for repairs or resupply or refueling. It's cutting-edge technology that has to be tested relentlessly to make sure it will not fail during this entire time and that it can hold up to the unimaginable stresses of space. So let's imagine we do that, and I think we will. And we say, okay, now let's upgrade that to do interstellar travel to get to the next nearest star. What you're saying is we need to upgrade this thing so that it can make that $500 billion Mars trip 700,000 times in a row without stopping. And some of you have already done the math and said, well, now hold on, if it takes months to get to Mars, that would take tens of thousands of years to get to the next star. And you're right, at the speed this thing goes, to make that trip in many thousands of times faster than this, meaning you need engines that are many thousands of times more powerful and that can carry many thousands of times more fuel. With even the most fantastic futuristic technology you can imagine, you still need a craft the size of a city because you have to bring everything. The people on here have to have everything they need to live for decades. The energy required to get this thing up to the speed you need it to go would be many, many more times than all of the energy ever produced on Earth combined. And I know what you're saying. You can't predict where technology is going to go. 200 years ago, they could not have conceived of something like an iPhone. That's true, but this also proves my point if you stop and think about it. The technologies you need to casually invent in your science are possible. Like the ability to produce a near infinite amount of energy from a tiny amount of fuel, or the ability to manufacture infinite food and water and medical supplies out of thin air. The last thing you would ever use them for is to travel to another star, because you're talking about technologies that would render life on Earth a utopian alien paradise beyond all imagination. For example, earlier when I was talking about the incomprehensible timescales, some of you were shouting at your phone saying, what about hypersleep and suspended animation? But think about what you just said. Look, to do this, all we need to do is to solve for human immortality, to find a technology that makes the human body not age. So what you're saying is that in order to make this possible, you simply need to get life on Earth to a stage where everyone is basically living as a god. By the time we got to that point, there would be no reason to do this. If the issue is running out of room on Earth, we could build an orbiting megacity that could house 100 million people. That would be much, much easier than this. And if you say, but the natural instinct of humans is to go out and explore and to colonize other places, my answer would be that we actually have a planet very nearby that is very similar to Earth but just has some very harsh conditions, and we've not bothered to colonize it yet. It's called Earth. Most of our surface is ocean, and we've not built cities on the ocean floor because why? Nobody wants to be trapped inside a tiny pressurized facility in a hostile environment cut off from everything. And the better and more comfortable life becomes on land, the less appealing that looks. This is fantasy in the same way that The Lord of the Rings is fantasy. It's just a mechanism for storytelling, for heroism and adventure. But we have no possible future that actually looks like this.
That's interesting. Do you don't have the guy's name, because I downloaded the clip and I I'd like to put a name to it.
Yeah.
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 I know his name, but I can't tell you right now because I can't remember. It's on my Facebook feed. He's got tons of good content.
All right.
That was really good. I enjoyed listening to that.
Yep.
You ain't going anywhere.
There's more physicists as well that have gone through all the actual math and they can show it to you, like the fuel to ship size ratio, the radiation shielding to ship size, ship to fuel weight ratios. And in order to supplant them, you have to add more fuel, which means you add more weight, which means you need to add more fuel. It's like an insurmountable physics problem. And he's right. The only solution out of it is magic, literal magic.
I don't know, man. If we roam around the planets, is there any kind of other element? Like we know the elements on our Earth that producing that kind of energy. Maybe there was another element that can produce far more energy.
Whoa, bro, what do you mean? Isn't it E equals MC squared? Oh, you're just gonna throw E equals MC squared in the trash can?
No, I'm not saying that. I'm saying about the element of the energy.
Dude, the only way to convert elements into propulsion is to either mechanical propulsion, like in a tire with a controlled explosion, or an expulsive explosion, which thrusts you in the other direction.
You are going into a theory part. I'm not going into a theory part. I'm talking about
Well, hold on, brother. I know, but listen, I'm telling you, physicists have actually done the math on if you power your engine with the largest nuclear explosions we know of. That wouldn't even be sufficient. So if you had a nuclear explosion going off in the back of your ship every nanosecond, it wouldn't be enough propulsion to get you there.
All I want to just say that there are certain things that humans don't understand, and maybe there
like
are
magic.
more things. Yeah, you can say the magic. There are more things that are ready to be undiscovered or waiting to be discovered. I'm just saying that.
But you know what, friend? There are some famous guys in the history of heliocentrism that have actually tried to solve this problem by appealing to the supernatural. So, in other words, in their own words, they want to tap into otherworldly, extra-dimensional, sentient entities that have power of a Cthulhu Lovecraftian nature to get their energy and bring it into our dimension so we can power space flight and all this other fantasy nonsense.
Yo. Hello.
Hello.
Is the sun flat as well?
Who cares? Why does that matter? The hell's that got to do with anything?
If the sun's also if the sun's a sphere, then it makes sense the Earth would be a sphere.
Well, how does that make sense? Explain it to us.
Because gravity.
Because the sun's a sphere, the Earth would also be a sphere because gravity. That makes no sense, bro.
Because gravity is the mass. So you have the sun being a big ball of mass. Then you have the Earth, apparently a disk. How would that disk not collapse on itself and then create a sphere?
Gravity is a natural force that pulls objects toward one another.
Okay.
And also,
that was excellent globe proof.
Yeah, that's awesome globe proof. Are you going to let me answer your question? Or are you going to answer it for me? Okay. First of all, you said a lot of things wrong. Okay. We don't think the Earth is a space disk orbiting the sun. Okay. And no, the Earth would not collapse because it's made of solid material. So even if I granted you the entire theory of gravity, does not mean the Earth would collapse. I can give you an academic paper which demonstrates this. So regardless, It doesn't logically follow that because the sun is a sphere, the Earth would be a sphere. That's a non sequitur.
Could you send me over like the academic paper?
Yeah, hold on.
Thank you.
Okay, so if your theory was, so say you have let's accept your hypothesis. You have a hypothesis. Gravity would form the Earth into a sphere. Shouldn't we be able to measure that? The Earth to actually be a sphere? Wouldn't we have to confirm that by measuring?
So what we can do is
Would we have to confirm it? The hypothesis.
We can confirm it.
Okay, yeah, so that's how science works, right? You have a hypothesis, and then you do an observation, a test, a measurement to confirm your hypothesis, right?
I've done one. I'd love to share it with you, my friend.
Please do.
What's
I can prove. Hold on, brother. I offered an experiment, so he said I could show it. So I'm gonna tell you my experiment. So I proved that something where the tension is linear across the plane will not collapse. It's called a bicycle tire.
Huh? I don't get that.
Yeah. Listen, a bike tire is round. It's oriented in a planar fashion around an axis, and then it's connected with wires which are pulling equally in every direction, yet it doesn't collapse. There you go, proven.
A bicycle tire is a useful analogy, but it doesn't apply to planetary bodies like Earth. A tire is held together by engineered materials and internal air pressure, not by gravity alone. Planets behave differently.
Dude, gravity doesn't make up structures, my friend. Holy crap. I yield the floor.
Gravity
All right.
does hold stuff, though.
Just quickly, Stitches. Right. So Rabbit has been here before in an event where we said free nitro for a proof of the globe. So they said, is that still up for grabs? So they said that they the globe, and so go ahead, Rabbit. Present your globe proof.
One second, Rabbit. Stitches, it's in the chat what you wanted, the academic paper.
All right.
Wait, just check this out. Keywords. Who's this by? This is by AC Top.
Okay, do it. Mute yourself, bro. We don't want to hear you think out loud.
Sorry.
If you don't mute yourself, I'm going to mute you.
Okay, so we.
So I can start?
Yeah, go ahead, Rabbit.
Thank you. My name is, you can call me Rabbit. So I would like to start with, if it's possible, to hear your theory so I can break it down for you, DJ, please.
What's that?
Yeah, I just want to hear why Earth is flat, just from your perspective, so I can break it down for you.
Oh no, you're supposed to be proving that the Earth's a globe.
Oh, is that only that way?
Well, that's what you said. Okay, so you said when can we start? But before that, you said you could prove that the Earth's a globe. So, can I still prove it and get nitro? And I said yes. You have the floor in VC. So, did you mean prove the globe?
Yes.
Okay. Well, go ahead.
Right. So, the Earth is a globe, not flat, and there are several clear lines of evidence that prove this. This proves direct observations, simple experiments, and etc. Let's start from lunar eclipse shadow. During a lunar eclipse, Earth passes around shadow on the moon. Only a spherical object always casts around shadow from any angle. Our time zone and sun movement. The sun rises and sets at a different time across the world. This is because the Earth is round and rotates. Okay, you might be hearing airplane ships, so I will skip that. Or star patterns. The stars you see at night change as you travel north or south. This shift matches what we would expect on a curved surface. So this observation together make a strong case that Earth is a globe.
Okay, so all of those explanations pre-assumed that the Earth is a globe in the first place. So that's what we're trying to get to the bottom of. So we're looking for empirical evidence that the Earth is a globe, because that's the prerequisite of all of those claims. So you know what a prerequisite is, right?
Yep.
Yeah, so we're looking for the prerequisite to be validated in reality. Not just explanations. It's like, well, if the Earth was a globe, then when we see an eclipse, it would be caused by the curvature of the Earth, or this kind of thing.
Sure.
It's you know what I mean?
Yeah. To give empirical evidence that Earth is a globe, we need proof that does not assume around Earth in evidence. This means using direct measurements and experiments anyone can repeat without just trusting image or authorities, right? So I will start like say high altitude balloon footage. Anyone can launch a weather balloon with a camera. At high altitudes, the horizon curves, and the higher you go, the more obvious the curve becomes. It's first. Over 2,000 years ago, Eratosthenes.
Oh, don't do it, Rabbit. You're just reading some bullshit. We're not doing that. I knew it.
All right. No, I'm not reading.
Okay, first of all, the first thing you read, yes, you are. You're literally going down the line. You think you're the first person that's read this shit to us?
Okay,
I've been doing this almost a decade. This is probably the 500th time I had one of you people read this to me.
I'm saying, and you have just to say something against it. So
I will. First of all, if that was true with what you said about the balloon, then you live on a tiny Earth, because you can't see a curved horizon from the altitude that a weather balloon goes. They only go up to 130,000 feet. 130,000 feet above an 8,000 mile diameter ball. No, you wouldn't see the curve of the Earth. And this is even demonstrated. Neil deGrasse Tyson, the scientist, Felix Baumgartner did this. See, the highest skydive ever, 128,000 feet, and it showed the curve of the curve of the Earth. And even Neil deGrasse Tyson admitted that it was because it was a fisheye lens. It's not the curve of the Earth, and it can't be the curve of the Earth. It's nowhere near high enough. It's not even close to high enough. It needs to be like 100 times higher than that.
Well,
100 times.
They bend straight lines, making the horizon appear much more curved than it really is. Neil deGrasse Tyson and other scientists have pointed this out, right? So, let's say mathematical evidence. I can even if the curve isn't.
It's geometrically impossible. If the Earth is a ball of 3,959 mile radius, going 130,000 feet above it is not high enough. It's nowhere near high enough. You know the ISS, Rabbit? The ISS? How high is that?
Yeah, wait.
How high is the ISS, Rabbit?
What?
How high is the ISS, the International Space Station? How high is that?
It's something like
400 kilometers.
400 kilometers, yeah.
Okay. What percent of the Earth do you see from there?
I would go with that 100 million kilometers square.
It's 3%.
Yeah.
3%. 3%. And you're telling us something that's more than 10 times lower. It would see less than 1% of the surface of the Earth, but you're saying that they see curve from a hot air balloon. It's nonsense. It's utter fucking nonsense. Okay? Stop reading stupid ChatGPT and Google.
No. It's easy to mix up visible radius from the ISS with area, but area increases much faster with distance.
Dude,
the ISS provides a broad view.
No, we're talking, look, brother, the area of what?
What do you mean? We're talking about the area of Earth's surface that is visible from a certain altitude.
That's right. It's a cone, right? It's a cone. So the cone is the horizon that encircles you. They're seeing 3% of the surface of the Earth from ISS, the circle. But they're not seeing the entire circle. They're only seeing a little teeny portion of that, right? Say their field of view is 90%. So now they're seeing like 1% of the surface of the Earth.
Yeah, exactly. The visible area from the ISS forms a cap on Earth's surface, defined by the horizon forming a circle around the observer. So this cap is the result of a cone projecting from the ISS down to the surface.
Okay, yeah, but you wouldn't be high enough to see the curve of the Earth. You're not far enough away, dude. What aren't you getting?
No, listen.
Okay, I'm going to show you an image. Okay, this guy is from a video. He did a presentation on flat Earth. He is a planetarium director. Okay, he made a scale model of the Earth and the horizon. That what would be the ISS horizon. See this? That circle? That circle would be the entire horizon. How the fuck are they going to see the curve of the Earth? You got to remember, they're in the center of that circle. It's going to look just like a flat line.
Wait. I'm gonna
hold on. I got another. I got a GeoGebra diagram too.
No, I'm gonna let me do it on order.
Okay, so look at that. So look at that. That would be the ISS above the surface of the Earth. See how high it is? It's not high at all. Your balloon is 10 times lower.
Okay, so look, I'm gonna use geometric relationship and real world numbers to clarify the misconception. The ISS is only about 6% above Earth's surface relative to Earth's radius, so it visually appears close to the surface in diagrams, but this is still high enough for the curvature to be visible. You want to do math? Okay, so Earth's radius is our. Why?
You're just claiming it. It's bullshit, dude.
I'm not.
Why are you comparing the radius to its height? The diameter is 8,000 miles. Listen, bro. It's the diameter of the Earth is 8,000 miles. The ISS is 250 miles up.
No, it's at.
No. Look.
Don't try to correct me, dude.
No, the claim that ISS at only 150 miles up compared to Earth's 8,000 miles diameter is too close to see Earth's curvature is incorrect. Even at this
it's not a refutation, dude.
Even at this small altitude, the basic geometry just shows that the curve is clearly visible from orbit. Look.
Clearly.
150 miles is about 2% of Earth's radius. It's like 8,000 miles diameter equal 4,000 miles radius, right? So 150.
Dude, the horizon distance from the ISS is 1,400 miles away. What are you talking about?
Well, look.
The distance to the horizon is 1,400 miles.
From the ISS at around 150 miles, about 240 kilometers. Altitude in roughly 1,400 miles in all directions. This figure comes directly from geometric calculation.
Yeah, you're just reading ChatGPT, dude. I told you not to do it. I told you not to do it, dude. I told you not to do it. Rabbit.
Hey, Indio, if I make an edit on Wikipedia, if I make an edit on Wikipedia and post it to Reddit, will he all of a sudden read it?
Maybe.
Oh man.
I also looked at the
typing our answers into ChatGPT and then parroting back what ChatGPT says. Dude, that's freaking retarded.
Yeah, I got a question. In projective geometry, how can you tell the difference between a straight line and a curved line?
They have no idea what projective geometry is. Projective geometry is how we see and how we make computer video games. So the 3D world is projected onto a 2D plane. That's how we see. He's sitting there saying you would see curve. No, you wouldn't. The horizon is equidistant in every direction. You have to be sufficiently far enough away from the ball to see the ball in its totality. At best, you would see a circle, but you wouldn't see a ball.
Can I ask a quick question? Like, someone gave me like an air pressure thing is the reason why we have like what we know as gravity. Like, gravity doesn't exist according to y'all, but air pressure does. But the thing is, air pressure doesn't actually affect weight all that much. You'd actually have to be at a really high air pressure for it to actually keep stuff down. And if we're at that high an air pressure, our eardrums were bursted by now. And
I have no idea what you're talking about or even referring to.
An exercise on Gauss's law of gravitation, the flat Earth PDF.
What about it? It has nothing to do with air pressure in that. What are you talking about? You said gravity couldn't work on the flat Earth and it would collapse into a ball. It's bullshit.
Yeah.
Yeah, that demonstrates it's not. That depends on this. It depends on the size, the density, shape, the orientation, and the mass distribution.
The vacuum primitive. So the vacuum will be like also air pressure as well.
It has nothing to do with air pressure. This is about gravity.
Actually, I have a
Yeah, dude, you're mixing up two things. You're mixing up what you read in the paper and what you heard somebody say. That has nothing to do with the
Can
paper.
I ask a question?
Get this math whatsoever.
They're integrals, dude.
Yeah, I know, but I just don't get how this works.
Okay.
I'm not ChatGPTing,
Because
but can I ask a question?
hold on. He doesn't understand how it works. Can I explain it to him, Sinner? Okay, it's going to take 1 second. Now, Gauss's law of gravitation is mathematically equivalent to the inverse square law. So what he does is take a Gaussian sphere and he calculates the gravity vector, because you get the integral, right, which is a little teeny freaking area, and then you get the normal to that integral, which is perpendicular to that area, and you get the direction that gravity is going. Okay, what he's demonstrating in it is that the disk of the size he says is that all the gravity directions would be parallel, and it would be indistinguishable from being on a ball. But if you do the Vsauce, they said, oh, because gravity points to the center, all of these lines are, the further you get to the edge, the more it's going to be tilted, and that gravity will cause some sort of gravitational collapse. Now, that's just bullshit. He never did the calculation. But all this is whistling past the graveyard in the first place. Do you know why? Because we don't have any observations of gravity forming anything into a ball ever. Not once, not ever. So what are we even talking about?
So
Fantasyland.
I can actually give you a little bit of a thing towards that. So we know that space and light travel at a certain amount of distance.
Yeah, do we?
Over time. Yeah. So, like, let's say a planet a million light years away collapses into a ball. Like,
we don't know that, dude.
Yeah, I know,
Okay.
But listen to hypothetical.
No, I don't want to hear your hypothetical because it's based upon the cosmic distance, lad. You don't understand.
Dude, this is going to be an appeal to the future, appeal ex ante, logical fallacy. It's going to happen in the future. The light will eventually get to us, and we'll be able to observe it in the future. Holy crap, bro. Try harder.
Look, the claim
I do find the light thing interesting, though, because we can technically see ancient Egyptians building the pyramids as well. From a
were you here listening to the freaking... Did you hear the audio I played?
Play it again.
No shit, dude. We're like straight in imagination. Man. He thinks he's going to look through a wormhole and see the ancient Egyptians building the pyramids.
What's the wizard's name?
You need
a wizard
you
did
need
it.
exotic matter. You'd need exotic matter to open up a wormhole, which
unobtainium. Yeah, it's called unobtainium.
Right. To see the Egyptians, hold on, friend. I'll stop. See the Egyptians, right? You'd have to be going past the speed of light, get out to the distance equal to the time traveled. You would then need an optic able to resolve the light that is spread out according to the inverse square law. You would need a lens the size of half the universe. Holy crap. You didn't think that one through, did you?
Might be possible. You never know. Some point in time. Also.
Okay, so let me get this straight. Your arguments require on the logical fallacy appeal to the future. That's your position?
I do believe the future holds our answers. Eventually, with time, comes answers.
Right.
Right,
and so eventually time will reveal to you the Earth is flat. So I can appeal to the future too.